Identification of bubbles in financial asset prices is an important topic in financial econometrics that has received considerable attention over the past 15 years. EViews includes tests for detection of bubbles based on the ADF unit root tests of Phillips et al. 2011 and 2015. To demonstrate these tests, we'll use some simple monthly data from 1950 through 2010 containing the S&P 500 price-dividend ratio. This is a standard financial instrument and often used as an example of bubble testing. From a graph of the data, we can see there are definitely periods of peaks followed by dramatic falls. But were these periods bubbles? To answer this question, we can click on View, Time Series Diagnostics, Bubble Tests. EViews offers three types of test: the rolling ADF test, the expanding ADF test, and the global ADF test. Each of these tests are based on the ADF unit root test estimated over a large number of small subsamples. The general idea behind these tests is that a bubble is a temporary explosive process, and so a test for a hypothesis of no bubbles is a test that there are no explosive unit roots in small subsamples. The rolling ADF test has a fixed subsample window that it rolls through the data. The expanding ADF test uses an initial window size and then increases the sample by one observation, one by one. The global ADF test does a combination of expansion and rolling. The rolling ADF test is the simplest to compute, and so that's where we'll begin. We'll use EViews' default window size of 56 observations, and then choose to include only an intercept in the ADF regression, since the underlying data didn't appear to follow an obvious trend. We'll also choose to stick with the default of 4 months of lags in the ADF regression, and keep the p-value bootstrapping options at their defaults with around 10,000 replications. Clicking OK runs the procedure. Since a large number of ADF tests are performed, and each has 10,000 replications, it takes a little time to run. The results show the rolling ADF test statistic for the null hypothesis that there is no bubble in the data. The bootstrapped p-value in our case is a little indeterministic. It fails to reject at a 5% significance level, but does reject at a 10%. The test identifies April 1998 as the most likely date for a bubble to exist, if one does exist. We can see the rolling statistics in graphical form below the table, with the orange line indicating the 95% confidence interval. Any time where the statistic is above the line suggests a possible bubble. For a second opinion, we could run the expanding ADF test instead. Again, we click on View, Time Series Diagnostics, Bubble Tests. But this time we change the type to expanding and keep the rest of the options the same. We can see this test is a little less wishy-washy in our case, and rejects at the 5% level. The graph statistics show a clear spike in the late 1990s, suggesting there may have been a bubble forming then, with July 1999 being the most likely date to be in a bubble.